To start this titration, we are pipetting 25 milliliters of 0.1 molar acetic acid into a beaker to be titrated.
Drop the pH probe in there and be sure that it's reading approximately the right pH. And because it's showing an acidic solution and it's been calibrated, I'm pretty sure it's the correct pH. Okay, so we're going to now fill the burette with our titrant, sodium hydroxide, which is approximately 0.1 molar solution as well. I'm using this volumetric pipette to avoid splashing. We place the sodium hydroxide in the top of the burette using a funnel. And we'll repeat this several times until it's full.
Then we add three drops of the indicator phenolphthalein to our acidic solution. And then we begin to titrate.
Now we are going to add 5 milliliters of sodium hydroxide. Now remember to always read the burette down, so we are going to stop at the 20 mark. And so let's add 5 mils. And as you can see, our pH after 5 mils has changed to 3.96.
So as we approach the equivalence point, we're starting to see the purple color from the phenolphthalein indicator staying a little bit longer than usual in our solution. Let's see if I can get it to do that. See, the purple color is very, very faint. You might not be able to see it on the video, but I assure you it is there. And we're actually having to stir the solution for it to go away, which means that we're getting closer and closer to our endpoint, and our solution is becoming a lot less acidic. As indicated by the pH, it's at about 5.84 right now. So I'm going to keep adding relatively slowly here until I can't get rid of the purple color by stirring anymore. And that went away, so we'll add more. It's pretty clear. There's our endpoint. Stirring Does not make it go away. Oh, yeah, the pH is also clearly indicating that we've reached the equivalence point. I mean, it's now an actually basic solution, which is just corroborated by the purple color. So after the equivalence point, we can see that the solution is just becoming more basic, and we should see it become more purple. Maybe not, but the pH is definitely rising. I think we've reacted all of our indicator, and that's why it's not turning any more purple. But we can definitely see the pH consistently rising.
There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium.